Okay, in mixed question 7 we've got a normal distribution and the height has this normal distribution with mean 40 and variance sigma squared. And we know the probability that the height is less than 32 is 0.2. So we can do normal distribution here, mean 40, that's 32. And let's compare that to a standard normal distribution of mean 0, sigma 1. And by using the inverse normal button on the calculator, if we know that this area here is 0.2, looking up inverse normal, this is minus 0.84. So we can compare the two diagrams. The gap between 40 and 32 is the gap between 0 and minus 0.84. So standardizing it, 40 minus 32 over sigma equals 0 minus 0.84 over 1. So from that, sigma works out to be 9.52. It's worth bearing in mind that the height is a continuous variable, so we don't need a continuity correction here, because we could have 31.999 there, or we could have 32.001 there. It's worth bearing that in mind for part B. Okay, let's look at part B on the next screen. So we're told that the probability that h is less than 32 is 0.2, and we're going to have 90 of these tennis balls bouncing. So we're going to have a binomial distribution with 90 events and the probability of success being 0.2. So from that, mu equals np, that's 90 times 0.2, that's 18, and the standard deviation is the square root of np1 minus p, which works out to be square root of 90 times 0.2 times 0.8, so that's the square root of 14.4. So what we're going to do is we're going to have an approximation here, and we're going to normally have a normal distribution approximating these 90 events. The mean is 18, so that means this number here is 18. The standard deviation is the square root of 14.4. And we want the probability that more than 19 of these 90 tennis balls have a height of less than 32. So that is a discrete distribution. So this point here has got to be 19.5. Bear in mind that all of that there, where this point here is 19 and that's 18.5, all of this area represents the probability that 19 of them have this height less than 32. So we need the continuity correction. That's got to be 19.5 there, because we want more than 19, and this area here, this whole area here between 18.5 and 19.5 represents the probability that is exactly 19. But we want more than 19, so this is 19.5. So looking this up on the calculator tables gives 0.3463. The lower number is 19.5. The mean is 18, and the standard deviation is the square root of 14.4.